So this is problem number 9. It's from the 2012 AP Calculus multiple choice set. Non-calculator question here, and they give us a piecewise function f of x. So as long as x does not equal 2, the function is going to be defined by this rule. And then when x equals 2, the function is going to be defined by an unspecified value k. And so you've probably seen questions like this before, and you're going to have some variation of this sort of problem within your multiple choice set. We want to let f be defined by the function above. Yeah, we've already looked at it. For what value of k is f continuous at 2? So you do have to make sure you're doing the appropriate thing. One version of this type of question can involve ensuring differentiability. You'd probably have more unknown constants if that were the case. In this case, we just want to ensure continuity. So a function is continuous at a spot if the limit exists as we approach that value, if the function value is defined at that spot, and if those two things, the limit and the function value, are equal to each other at the x value under consideration. And so we don't know what the function value is at 2. That's what we're looking for, right? We're trying to specify what that function value needs to be at 2 in order to make this continuous. But we have what we need to check the limit, because when we check a limit, we're not necessarily concerned with being right at the value that we're approaching. We're concerned with just approaching that value. So from either side of 2, the limit as we approach 2, smaller side or bigger side, would involve this rule for the function. Now this is given to us in a pretty beneficial form. If you put in 2 in place of all the x's, you are going to get 0 over 0, and that's pretty typical. You're going to see that in the majority of limits that you're asked to check on the AP exam and throughout your calc textbook. But in this case, we already have the top of this expression in a factored form, and we have a shared factor from the top with the denominator, and we can go ahead and cancel those shared factors, toss in 2 in place of the only x that's left, and evaluating gives us that the limit equals 5. Well, if the limit equals 5, and we're trying to force this function to be continuous at 2, we need the function value at 2, which is k, to also equal 5. And that is it for this one.